Here I have three modules. This is a 6-port, this is a 2-port, and this is a 2-port. So in total, I have a 10-port VNA. One is a 20 gig, one is a 50 gig, or one is a 44 gig. But when they load up together, it ends up with a frequency of the lowest system, in which case it's a 20 gigahertz. The lowest one is 20 gigahertz, so it'll be a 20 gigahertz VNA. We'll wait for it to load up.
So it's not. So we basically have to map out something like we do on the field box. Who is going what, and then when you reach out to that person.
And if you go to the help about, you can see the three VNAs. So module 1 is 6 ports, M9804. Module 2 is a 50 gig 2-port, and module 3 is the new M9837A. This is actually a 2-port, but so we're limited to 20. So I go and I set up my waves as my first one is my B2 source port 1. Then I do B3 source port 1, B4 1, B5 1, B6, B7.
No, we wanted, and one at a time.
8,
correct.
and
not
B9.
Like, not the,
1. If 1 was the transmitter, and then it was going into all these receive ports were measured, and these are all measured together at the same time, as long as they're in the same frequency. If you change the frequencies, different frequencies measured are different sweeps. And the B9 is also the one that's so you see ports 9 and 10 get this new configurable test set. These other ports don't have it. It's only for 9 and 10. And I can go into the receiver, and on B9 I can say bypass auto. That can bypass the coupler, and it kicks in an LNA. It says factory cal turned off, but you see the noise floor drop. So it has a lot more dynamic range, so theoretically you can run at a wider bandwidth to get the same noise floor. So that's the point. But you can measure all of these at the same time.